Click the bell icon to get latest videos from Ekeeda.
Hello friends, so today we are going to learn about eigenvalues and eigenvectors, and particularly in this video we are going to focus upon how we can use eigenvalues and eigenvectors in order to calculate function of any square matrix. So in this particular video we are going to focus upon how to calculate a function of any square matrix. Any square matrix of higher order, let's say a raised to 50, or particularly tan of angle A we calculate. But in this particular video and in this particular chapter we are going to focus upon how to calculate tan of any matrix A. So there are different functions. We can have e raised to a, tan a raised to 50. These higher functions, how we can calculate using eigenvalues and eigenvectors. Before going to solve any sum, we are going to focus upon what is the theory behind it. So let's focus on it. So when we say two matrices are similar, let's say A and B, so we write down as B is equal to M inverse into A into M. But in case this particular matrix M inverse into A into M turns out to be D, which is the diagonal matrix, so M inverse into A into M is D, then we say matrix A can be diagonalizable and only diagonal elements are present and other elements are 0. Let us consider D square. In particular D square, I am going to have D into D. So I'll write down the value of D, which is M inverse into A into M twice, into so while calculating, I am going to focus upon these middle terms, M into M inverse, and the product of M into M inverse is going to be an identity matrix I. So I am going to write down. So in this case, I acts as 1. So any number can be multiplied by 1 and we can get the same number. Just like that, in matrix we have I, identity matrix. When it gets multiplied by any other matrix, we get the same matrix as an answer. So in this case we have A into I into A, which is A into A square. So I'm going to write down the A square. Therefore we have got D square is equal to M inverse into A square into A. So basically, by definition we can have A square and D square, these are diagonalizable. Therefore I can have D raised to N is equal to M inverse into A raised to N into M as my result. Now to take this one step further, I am going to use pre-multiplying and post-multiplying by M. So in this particular equation which we have derived, D raised to N is equal to M inverse into A raised to N into M. So now I am going to post multiply by M. Now we have got D in terms of A. Now I want A raised to N in terms of D raised to N. So I am going to perform this step. Therefore M into D raised to N is equal to M into M inverse into A raised to M into M. Now in this particular case, M into M inverse is going to be an I, identity matrix. So I'm going to write down. When any matrix gets multiplied by an identity matrix, we get the same answer. So I into A raised to N is nothing but A raised to N. So in this particular case, in order to eliminate this M, I am going to post multiply by M inverse. So we have multiplied on M inverse on left hand side as well as on the right hand side. So M into M inverse is going to be an I. And of course, a raised to n into I is going to be a raised to n. Therefore, I can have a raised to n is equal to m into d raised to n into m inverse. So this a raised to n can be termed as function of matrix A. So in order to have any calculation about the function like tan of matrix A, e raised to exponential of matrix A or sine of matrix A, I am going to perform the same step on its diagonalizable matrix, that is D matrix. So if we have got tan of A, so I'm going to have tan of d raised to n, and of each and every element I'm going to multiply, and we are going to multiply the same with m inverse into d raised to n and m to get the desired result. So let's focus upon the problems. So we have got a problem over here. Find e raised to a and 4 raised to a if a is equal to 2 by 2 matrix, 3 by 2, 1 by 2. So we have never calculated exponential, that is e raised to of matrix A. We have never calculated tan of any matrix A. So in this particular problem, we are going to focus upon how to do it. So let us focus. So before that, let's talk about the procedure of the same. In order to have the model matrix, we are supposed to calculate what are the eigenvalues and eigenvectors of the same. So first step is to calculate the eigenvalues and the respective eigenvectors. Then we will construct a model matrix M and find the M inverse. And what is the function which is e raised to a and 4 raised to a, which we are going to apply on diagonal matrix, which is nothing but the eigenvalues are written in the diagonal form, and the function we are going to apply on matrix D, and the same result will be obtained by multiplying m into d raised to n and into m inverse, and that is nothing but the problem. So let us get started. Let us find out the eigenvalues and eigenvectors of the same by starting with the characteristic equation. So a minus lambda, I am going to subtract lambda from all the diagonal values and take the determinant of the same. So in order to calculate this determinant, what we are going to do is multiplication of the diagonal minus multiplication of the other diagonal elements. Is equal to 0. Therefore, I am going to apply a minus b square, which is a square minus 2b plus b square. Therefore, 9 by 4 minus 3 lambda plus lambda square minus 1 by 4 is equal to 0. Now 9 by 4 minus 1 by 4 is 8 by 4, which is 2. So we are going to have lambda square minus 3 lambda plus 2 is equal to 0. Therefore, if we solve this equation, the roots should be such that the product should be plus 2 and the addition should be 3. And for obvious reason, they are 2 and 1. Therefore, this is lambda minus 1 into lambda minus 2 is equal to 0. Therefore, lambda is equal to 1 and lambda is equal to 2. These are the two eigenvalues which we have obtained. Now we'll calculate each and every eigenvector for this particular value. So the case 1 we have considered lambda is equal to 1, and while calculating the eigenvectors we are going to consider about characteristic equation, which is a minus lambda I into capital X, which is eigenvector, is equal to O, which is null vector. In this case, a minus lambda I, so I am going to subtract this particular value lambda is equal to 1 from all the diagonal elements, from here as well as from here. 3 by 2 minus 1 is nothing but 1 by 2, and 3 by 2 minus 1 is nothing but 1 by 2. So in this particular case, you can see 1 by 2 1 by 2 as first row, and second row is also 1 by 2 1 by 2. So I'm going to consider either of the row, and I'm going to have only one equation out of the same. So we have 1 by 2 into x1 plus 1 by 2 into x2 is equal to 0. I am going to take this half out and divide by 0. So I am going to have x1 plus x2 is equal to 0. This gives me x1 is equal to minus x2. Now we have got two unknowns and one equation. So I'm going to have 2 minus 1 is equal to one parameter, and that parameter is nothing but x2. Let us put x2 is equal to t, which is one parameter. So naturally I'm going to have x1 as minus t. And therefore the eigenvector, first eigenvector x1 is equal to minus t and t. I'm going to have t common, so I'm going to have minus 1 and 1. Now let's put t is equal to 1 so that we can get minus 1 and 1 as my answer. So this was the first eigenvector, minus 1 and 1. So let us talk about the case number 2, which has got eigenvalue 2, and we'll calculate what are the values of eigenvectors. So case 2 is lambda is equal to 2. So case 2 is lambda is equal to 2. So I am going to subtract lambda is equal to 2 from all the diagonal elements. So let us focus on what was the original matrix. So I'm going to subtract 2 from 3 by 2 as well as from 3 by 2, which is going to be minus half and minus half. So let us write down. So here we have subtracted 2 from diagonal element as well as 2 from another diagonal element. So I'm going to have minus half over here, minus half over here. As we can say, if we talk about the first row, when we multiply this particular row by minus 1, I'll get the second row. Therefore, these two rows are nothing but same. So I'm going to consider only one row out of the same. So I'm going to consider first row as my answer. So we have considered first row, which is minus half into x1 and plus half into x2 is equal to 0. I'm going to take this first half common and divide by 0. So I'm going to get minus x1 plus x2 is equal to 0. So we are going to have half common and divide with this 0. So I'm going to have minus x1 plus x2 is equal to 0. So we have got minus x1 plus x2 is equal to 0. Therefore, x1 is equal to x2. And let us put x2 and x1 as t. Therefore, we can get x1 is equal to t as well as x2 is equal to t. Therefore, second eigenvector, which is x2, x1 and x2 is equal to t and t. And from that, we are going to take t common and we are going to have 1 and 1 as my final answer. Putting t is equal to 1 over here. So we have got second eigenvector as 1 and 1. So for the particular value lambda is equal to 1, we have got minus 1 and 1. For eigenvalue lambda is equal to 1, we have obtained eigenvector as minus 1 and 1. And for lambda is equal to 2, we have obtained eigenvector as 1 and 1. So I am going to construct modal matrix as well as diagonal matrix D. Model matrix M is considered as, we are going to take this first eigenvector and put it here column wise, and the second eigenvector we are going to take and put it in the second column. So model matrix is -1 and 1, and second column is 1 and 1. So I'm going to calculate now the M inverse of the same. Now how to calculate the M inverse of 2 by 2 matrix? So while calculating the inverse of 2 by 2 matrix, we are going to interchange the diagonal elements, that is -1 and -1. So these two elements we are going to interchange and changing the sign of the rest of the elements. So I'm going to have 1 over here, -1 over here, and 1 and 1. The signs of this one will be changed. So -1 and -1. Now I'm going to have the determinant of M. So let us calculate determinant of A, which is -1 into 1, which is -1, -1, which is going to be -2. So the value of this determinant is -2. Now this particular minus sign will go inside, and this will be -1, 1, 1 and 1. So I'm going to write the same. So M inverse is equal to 1 by 2 into -1, 1, 1 and 1. So let us now construct diagonal matrix D. While constructing any diagonal matrix of any order n cross n, I am going to write down all the eigenvalues in the diagonal form and the rest of the elements are 0. Since we have got 2 by 2 diagonal matrix over here, so I am going to write down λ1 and λ2 as diagonal elements and other elements are 0. So here we have got diagonal matrix as 1 0 0 2. Now in order to calculate any function of a square matrix, I am going to perform the same step on diagonal matrix D, and then we are going to multiply with M and M inverse to get the final result. In this particular problem, I am going to have exponential of matrix A and 4 raised to A. So the functions would be e raised to A and 4 raised to A. First of all, I am going to calculate what is the e raised to A. So the same function will be applied on diagonal matrix. So in this particular problem, we have got e raised to A and 4 raised to A as my function. So function e raised to A first will calculate. In order to calculate this e raised to A, I am going to apply it on diagonal matrix D. So we have got f of A as e raised to A, therefore the function D, e raised to D as, so it is applied only on the diagonal elements, which is e raised to 1 and e raised to 2. We have got f of A as M into f of D into M inverse. So let us put all the values of the same to calculate what is e raised to A. So we have got M as -1 1 1, f of D as e raised to 1 e raised to 2, which is the function applied only on the diagonal elements, and M inverse as 1 by 2 into -1 1 1 and 1. So let us multiply this from right hand side to the left hand side. First I am going to multiply these two particular matrices, and then answer will be get multiplied with this particular matrix. So while calculating this particular matrices, I am going to have this first row into first column, which is e raised to 1 into -1 plus 0, which is minus e raised to 1. E raised to 1 into 1, which is e raised to 1. 0 into -1 plus e raised to 2. E raised to 2. And here 0 into 1 plus e raised to 2, which is e raised to 2. So we have got -1 1 1 and 1. Here we have got minus e raised to 1, e raised to 1, e raised to 2 and e raised to 2. So in order to multiply the same, I am going to take first row into first column. So this is e raised to 1 plus e raised to 2. here minus e raised to 1 plus e raised to 2. Again here minus e raised to 1 plus e raised to 2 and e raised to 1 plus e raised to 2. Now you can put the values of e as 2.73 raised to 1 plus 2.73 raised to 2. It comes around 5.3, or you can keep the answer as it is. So we had got e raised to a as half into e raised to 1 plus e raised to 2, half into minus e raised to 1 plus e raised to 2, minus e raised to 1 plus e raised to 2, and e raised to 1 plus e raised to 2. In order to calculate what is the value of 4 raised to a, I am going to replace all the e's by 4, and in place of e we'll be having 4 raised to 1, 4 raised to 2, like that. So in order to calculate 4 raised to a, I'm going to have 4 raised to 1 plus 4 raised to 2, which is 4 plus 16 is 20. Minus 4 plus 16, minus 4 plus 16, and 4 plus 16. So 4 plus 16 is 20 and minus 4 plus 16 is 12. So 1 by 2 into 20, 12, all the elements will get multiplied by 1 by 2, and I'm going to get the answer as 10, 6, 6, 10. So this was all about the function of the matrix. Thank you for watching this video. Stay tuned with Ekeeda and do subscribe to Ekeeda.